Good day, everyone, and welcome to our webinar presentation. Today's topic is on thermal conductivity characterization of innovative building materials. Uh, this is an educational webinar designed to provide context and information on how best to uh, choose the appropriate method for characterizing a wide range of both traditional and newer, innovative, novel building materials. You'll see some content featured on materials, composites with aerogels, phase change materials. We've got some content with bio-based insulation. We're seeing a lot of research and development work in these areas and advancing new, novel, innovative materials of construction to help with the insulation quality of our buildings and overall improve energy consumption. So my name is Adam Harris. I'm Managing Director for C-Therm Technologies. I'll be providing a little bit of an introduction on the webinar. I'll be speaking a little bit to who C-Therm Technologies is, our background and strengths in thermal conductivity. And then I'm going to be passing this over to Sarah Ackerman. Sarah leads our application development group. It's a division within C-Therm called TAL for Thermal Analysis Labs. Sarah's group is supporting a lot of clients right now with contract testing requests. A number of folks are locked out of their lab due to different restrictions related to the COVID-19 pandemic. And really grateful that we could have Sarah join us online for this event. This webinar is one of the highest subscriptions we've had in terms of the different educational webinars we offer. I think we had 250 folks sign up for this. So it just speaks to the desire to learn more about this topic area, a keen interest. We've got folks from all over the world, from India. I see a number of participants from Spain, from Portugal, of course, throughout the US, Latin America. So really great to have you all online with us. And we are recording. We will post this on our website. You can share this with any colleagues that weren't able to be online with us directly. I want to provide just a little bit of background on C-Therm Technologies. I see a lot of familiar faces in the registration and participant list. See a number of our distribution partners around the world. I want to say thank you to them for joining us. They form a really important part of our support team and our global network. And we're very proud of this. C-Therm's developed an impressive global network of partners, about, I think 65 different partners around the world approximately. Providing great value added technical expertise, both pre-sale and post-sale. And we have a number of them on the line with us today. But C-Therm Technologies is an organization. We are really niche specialists in the area of thermal analysis related to heat transfer. So we're really good at this particular aspect of measuring conductivity and related heat transfer properties. We don't offer a really broad product line. What we do extremely well, and I would argue we're the best in the world at. And that is simplifying and driving innovation in the thermal conductivity characterization of a wide range of materials through the advancement of transient-based thermal conductivity methods. And there are a range of different methods that we advocate. And a lot of today will be focused on helping you understand the appropriate tool for the different scenarios you will face and characterizing the wide range of different formats you'll see in building materials, insulation, etc. We do want to be careful to recognize here that it's not business as usual. And if you've participated in any recent webinars with us, this is a slide that I am presenting in each one because this is one of our best opportunities to engage with a broad audience of our partners, of our customers, of different stakeholders that we care very much about. And the chat box gives us a little bit of an opportunity to get some feedback from you on how this pandemic is impacting your business. we'd love to hear any comments in the chat box. We've set the chat to private, so my understanding is only we are seeing that here at C-Therm. We're very interested to know if you're able to access your facility, uh, how long you see the current situation of restrictions lasting for you and your organization, and if there's any long-term changes you see to the industry in which you're operating in, it's a great opportunity for us to better understand that and try to solicit that insight. Some industries may forever be changed. I think of the airline industry as one example that will look very different when it does come back, in whatever that looks like, whatever timeline that is. But if there's any insight you can offer in terms of how this pandemic is impacting your business, your industry, that's really helpful. And I see a few comments coming in, and appreciate that insight. One way that we are supporting clients is in helping with contract testing. So I mentioned earlier that Sarah's group is providing contract testing services. A number of folks still have projects that they're trying to move forward. They have milestones they're trying to hit, and yet are maybe not able to access their lab. The situation at C-Therm is our facility is open with a reduced on-site staff. So we've sent most of our people to work home remotely, and that's created enough physical distancing within our facility that we can continue to manufacture. We're continuing to ship. The lab is fully operational, although at a reduced capacity. That means that we're still offering all of the test services, including dilatometry, thermal conductivity, laser flash, DSC, TGA, etc. So if we can be of any help there, if you'd like us to follow up there, please just use the chat box, and we'd be pleased to follow up accordingly. Okay, a quick orientation on our product portfolio. Today's webinar is really going to focus more on the two products to the center left. The one on the far right is a product that's oriented for the textile industry, consumer goods, automotive. It's to quantify touch performance. This is the TX Touch Experience platform. We're not going to talk a lot about that in today's webinar, but I will just note there is some application for it in different tiles. Touch is a really important aspect, and I know in flooring and in some areas of building materials, there has been some really novel, interesting work done. I know of a report in Mexico that was applying this type of technology to look at how porosity changes in the ceramic tile would lower the feeling of coolness when you walk on the tile. Sometimes that's not very pleasant. You get out of the shower in the morning and the tiles are cold, and you scurry over to the carpet. So that sensation, that feeling of touch, this is something that we do a lot of work in quantifying. Most of that is in support of the textile space. We work with groups like Adidas, number of major textile brands, and it's with the view of really quantifying that touch performance. I won't drive on that too much further. What we're really going to focus on today is on thermal conductivity and the characterization of a wide range of different materials. The product in the center, the one that kind of looks like the pyramid, this is Trident. This is a research grade instrument that brings together the three most prominent methods for thermal conductivity from a transient perspective. This is really the ultimate kit for characterizing thermal conductivity. Broad temperature ranges, high sensitivity, high accuracy, maximum flexibility overall. And Sarah will detail a little bit some of these methods and how they're applied in characterizing different building materials. The one on the far left is a thermal conductivity kit. It's paired with a Keithley source measure unit and a PC. It's kind of a build your own type scenario. what it does is it allows clients an ability to kind of get in the game in terms of measuring thermal conductivity. So it's used a lot with academic researchers that may be on a limited budget, used in different lab modules to teach concepts of heat transfer and thermal conductivity characterization. But it does provide a very good basic function for measuring thermal conductivity of materials, and it is applied in a limited research capacity in that sense as well. It doesn't have the same industry standards, such as the ISO 22007 qualification, as you'll see on the Trident platform. It has the same type of sensor, a TPS flex sensor, a transient plane source sensor, which Sarah will talk a little bit about that use of that on concrete and cements and some of those types of materials. But it doesn't have the bridge circuit design of the electronics that offers the sensitivity and accuracy, the performance, as well as the temperature range that it would be available on Trident. And we can get into those details more if you would like on a one-on-one basis. But what you'll see featured in the content that Sarah will present largely focuses on the MTPS method. That's the stainless steel cylindrical shaped sensor that you see on the right of the controller, the Trident controller. You'll see a little bit of content on the Flex TPS as well. It's very useful in testing concretes and cements. You probably won't see much of the needle transient line source in this presentation. It's reserved for more for testing soils, for testing very sticky materials that might bond to the sensor. So a polymer melt would be a good example. But with Trident, it's a platform overall that's really meant to bring together the best of those available transient methods. The tag on the product is that it's one instrument, but it's three methods for thermal conductivity. And in thermal conductivity, particularly when you're dealing with a wide range of sample formats, it's truly better to have options at your disposal. This just gives you a sense of the size of the sensors. So the needle probe is 150 millimeter in length. The Flex TPS sensors, those can come in a variety of sizes at 6, 13, and 30 millimeters. And then the MTPS has an active area on the surface of the sensor of 18 millimeters in diameter for the sensor. That would inform the minimum volume of material for you to test, to run a test. So the needle requires the largest volume of material. The Flex, you have to have two samples and you kind of sandwich that sensor in between the two samples. And then the MTPS has a very small active sample footprint, so you can get away with testing some of the smallest sample volumes. And you only need one interface with the sample, which gives you some advantages in testing irregular shapes and maybe some samples that are difficult to scale up or produce or to machine. Okay, at this point, I'm going to pass this over to Sarah, who's our expert in transient thermal conductivity measurement. She's a tremendous resource to us here at C-Therm, and I'm really pleased to be able to lean on her here and have her come in and share that expertise with you. She'll be highlighting some different applications. This is meant as a training session and understanding how to measure the thermal conductivity of some of these different materials. I know in her presentation here, she'll also detail some of the theory of operation to how those measurements work, which should help better inform you in terms of the capabilities of those particular methods, but also the limitations of where they should be applied. So with that said, Sarah, I'm very pleased to pass this over to you.
Thank you, Adam.
I have to stop sharing. Yes, there we go. Okay.
1 moment.
Well, Sarah's bringing up her slide deck. Anna, if you want to drop in the method selection guide link, one of the nice resources we've developed that Sarah was involved in co-authoring with others on the team is the method selection guide for thermal conductivity. And a lot of the content that will be presented today is also in that guide. It's a free downloadable guide. I think it's about 45, 50 pages. It's a very comprehensive outline of what is thermal conductivity, how do you measure it, what are the different options available, and something I'd encourage you to check out. And I see that Anna's entered that in the chat box for anyone that's interested. Okay, Sarah.
One moment, I'm having a bit of technical difficulties. Maybe we should put the intro up or something. 1 second, please.
Okay. While Sarah's troubleshooting the slide deck there, I would just reference a couple of other resources that are available. And I'm thinking of the application pages as links. There is a great application page dedicated, and what it does is it brings together all the different resources, webinars, peer-reviewed publications, application highlights, all these materials onto one page that you can reference. So there's one for the insulation materials. There's another, I think, for different building materials. Both of these would be of interest. And just give me a thumbs up if the audio is still okay. I'm getting some comments that there's a lost audio. Okay, great. The comments are streaming in. Thanks, everyone. Do you need me to try to load the deck, Sarah?
I'm currently uploading the slide deck on my local drive, so it
Okay.
will just take a moment. Okay, this should be good.
Okay.
Here we are. Perfect. I'm not sure why, but anyway, it doesn't matter. Let's get going.
Okay, perfect.
All right. So thank you very much for the generous introduction, Adam, and let's get going without any further ado. So the first one that we'll look at as far as application highlights. So my section is mainly focused more so on the application data than on the theory and experimental practice this time around. And this one is looking at making green composites, which are reinforced with natural fibers waste. And this one was published in Polymers this year. So this work used the Modified Transient Plane Source, or MTPS sensor, and so do the next few papers. So I won't review every time the principle of the test, but in short, the line art that you see on the right-hand side of the slide there is what the sensor looks like. And the 18 millimeter diameter circle highlighted on that line art is the active area of the sensor probe. When you're running a test, you just place your sample on top of that area. And you run the test. Sometimes you may need to apply a bit of a weight to ensure good contact. Like I mentioned, it's a single-sided sensor, and it also measures another related thermal property called the thermal effusivity. And the thermal effusivity is really what is interesting about the TX instrument that Adam had highlighted earlier in his intro section. And that method as a whole, which is available on 2 of our platforms, is compliant with ASTM standard B7984. Of the 3 methods we offer, it's the easiest to use and offers the best reproducibility in the data, in addition to being the most versatile, which is not to say the other methods are not without their strengths. All 3 methods are very complementary. So when you run a test with the sample on top of the sensor, if you take a close look at the sensor, what it would look like is a dark spiral trace on top of a green or white background, depending on the model of sensor. And that would be surrounded by a circular dark trace, which is our guard heater. So both the spiral and the guard heater fire at the same time. And what that has the effect of doing is ensuring there's no lateral heat or temperature gradient experienced by the sensor coil. The only gradient it experiences is in the direction directly up from the sensor surface, so normal or perpendicular to the sensor surface. What that does is let us take a good look at the thermal effusivity and also prepare a calibration for the thermal conductivity so that the end user does not need to engage in any kind of complicated regression analysis or anything like that. So in this paper, they use 3 different types of pore-forming agents, and all of them were bio-based byproducts of other processes. So one was a cotton fly, another one was coconut husk, and then the third one was the sugar cane waste. And then what they did was they fabricated with clay as the other material. They fabricated these, or sorry, with polymer resin. They fabricated these blocks with cotton, sugarcane, and again coconut. And that was used with the idea of improving the strength of the polymer material and also its thermal properties. So, um, as would often be expected, these kinds of organic filler materials tend to be fairly porous. You would expect, and indeed the researchers did observe, that the thermal conductivity decreased as a function of the filler volume fraction. Uh, it also appeared to relate to the filler porosity level, which is as would typically be expected, again, of this sort of relationship. The next one that we'll look at is titled Numerical Analysis of Phase Change Materials and Wood Plastic Composite Roof Module System for Improving Thermal Performance. So this was a paper published just this year, and it looked specifically at, of course, wood plastic composites, and specifically the use of phase change materials to regulate indoor temperatures. So phase change materials, as a refresher, they are materials that uh, store thermal energy or heat energy by a change in the physical state of the material, usually as it goes from solid to liquid and back again. So as it heats up, it changes phase and it melts from solid to liquid phase, and heat is stored in that operation. And then when the ambient environmental temperature decreases, it re-solidifies and then the heat is released again. These kinds of materials can cycle many, many times. Although some of them, especially the newer, more bio-based ones, can sometimes degrade over time. The classical petroleum-based PCMs, on the other hand, tend to be very stable even across many thousands of cycles. So the framework of this particular paper, what they started with was designing the module system that included the phase change materials, and characterized the thermal properties, including the latent heat capacity and the sensible heat capacity of the PCMs, and inputted the data into a simulation to determine how it would perform as a function of yearly temperature variations, both day-to-day temperature variations, as well as more broadly seasonal variations. So this is an example of one of these plots that was generated, and you can see the roof surface temperature is plotted on the y-axis, and the date and time is plotted on the x-axis. So you can see the daily variations in the roof surface temperature with different types of PCM. So this would be a PCM which was designed to melt at 20 degrees, which you can see in the pink, and one that was designed to melt at about 40 degrees, I believe. And you can see the variation in the temperature as a function of the time. This data was used to pinpoint the optimal roof cooling panel design. And that in turn was basically inputted into further design and optimization characteristics for the project. This one is from the Journal of Thermal Analysis and Calorimetry, and it's kind of a more survey style project out of the Czech Republic, where they were looking at the thermal conductivity behavior of roofing slates. So a bit of background on this. In the Czech Republic and other neighboring areas, it's quite common to use actually naturally occurring slate minerals as a roofing tile sort of material. And these are referred to as roofing slates. Usually the material is actually a type of slate that's used. You can see on the right a map taken from the paper that shows the sources of the different samples that were characterized during this work. And the color on the map indicates which sample was or which type of deposit was sampled. The mineral composition was characterized with XRD, and the thermal properties of the slate material were measured with the MTPS method that C-Therm offers. So you can see on this plot the anisotropic thermal conductivity behavior of these different slate samples. So some of them are quite anisotropic, with the basically in plane direction being twice or sometimes even closer to 1.5 times as thermally conductive as the through plane direction, and I believe in one case it's over twice as thermally conductive with the MOK2 sample. So what that shows is that these materials are much better at transmit at spreading heat than allowing it to penetrate through the plane of the material. And on this plot, you can see the thermal conductivity behavior in the direction that is identified on the previous slide as perpendicular. So it's basically in the through plane direction. And for these slates materials, as with most metamorphic and sedimentary rocks, you see that the thermal conductivity actually increases as a function of temperature. This is not uncommon for these kinds of materials. What this does indicate, however, is that the roof is going to be more insulative in cooler and in sun-shaded conditions than it would be in the heat of summer, which suggests that it will be more effective at retaining heat in the winter than it would be in retaining air conditioning in the summertime. The next one was published in the Journal of Construction and Building Materials. It's titled Comparative Study of the Use of Different Biomass from Olive Grove in the Manufacture of Sustainable Ceramic Lightweight Bricks. So this paper basically looked at 3 different types of biomass used as a pore forming agent. The first one is called olive pruning. The second one would be olive wood, and the third one would be olive leaf. And all of these are waste materials generated by olive production and farming techniques. So if you can reuse these waste materials, for example, as pore forming agents, you can reduce agricultural waste and also have some added product at the other end of it. So the experimental design basically generated 9 different types of samples and ran a test on several different pieces of each types of sample. 3 pore forming agents were used, and the first 2 letters of the sample code indicate which pore forming agent was used. The last 2 to 3 digits of the sample code, or of the sample code indicated on the brick, indicates the fill ratio. So the fill ratio was varied between 7.5% by volume up to 25% by volume. After the pore forming agent and the powdered clay were mixed by volume first, and then 10% of water was added. The resulting mixture was formed into a brick and pressed at 2.5 megapascals of pressure. Then it was fired in an oven up to 850 degrees Celsius, yielding the bricks that you see in the image on the right. So this slide shows the thermal conductivity test results, and specifically the effect of the pore forming agents on the effective thermal conductivity. And you can see also this plot has error bars, which indicates the relative variability of each of these formulations. The best results in terms of a balance of the measured thermal properties as well as the observed physical properties detailed in the paper were obtained with about a 7.5% by volume addition of a pore forming agent. The final slide is going to take a little bit of a change of tack, looking at the Flex TPS sensor using the transient plane source method. So this is a double-sided method, like you can see in the upper right. The data collected here were collected using a C-Therm TC kit, which Adam had mentioned earlier in the presentation. But you can also run a very similar experiment with a higher degree of precision using the Trident platform, as well, as the sensor type is available on the Trident thermal conductivity platform. So the transient plane source method, the probe looks, as you can see on the right-hand side of the image. So it's a very thin layer of nickel, which is etched into a double spiral pattern called a bifiller spiral. And then that is basically insulated on either side with a thin layer of polyamide, which is just there to act as a dielectric material and electrically isolate the probe material, which is made of nickel. We call it our flex sensor because it does offer the user the greatest level of flexibility over experimental parameters and minimum sample size. But it is a bit more demanding in terms of the technical acumen required by the user to attain good test results. So we do recommend it for those who are a bit more experienced with thermal conductivity analysis and the kind of conditions that you need to respect in running these kinds of samples. No contact agent is required to operate this sensor probe, and specialty modules for testing SLAD style, which are basically sheets of material, as well as anisotropic samples are available. As Adam mentioned earlier, this method does comply with ISO 22007-2 when you use it with our Trident platform. So when you're running the test with the flex sensor, you place the sensor probe in between two identical pieces of material. The data presented here uses the bulk algorithm, so the sample should be at least 5 times the sensor radius in diameter and at least twice the sensor radius in thickness in order to achieve a good test result. A constant heat flux is applied across the bifilar spiral heating element, and the temperature is measured as a function of time. The analysis of the shape of this temperature time plot is what gives us the thermal conductivity and the diffusivity. So when you're looking at construction materials, many of them are highly porous and hygroscopic. So if you're using a test method that requires a contact agent, it can be difficult to test them with that kind of a test method. Like, for example, a heat flow meter type of method would require a contact agent as one example. So the fact that the flex method does not require a contact agent becomes pretty attractive in these kinds of cases because you don't have to worry about the sample absorbing the contact agent and increasing its effective thermal conductivity as a result. The other advantage of using the flex sensor for these kinds of construction materials is that, especially with concretes and brick and type of materials, they can be quite abrasive, and that can have the risk of damaging some of the more delicate types of methods out there. So, because the flex sensor is, as the name would imply, quite physically flexible, it's much less likely to risk being damaged when you're testing with a rough surface or a highly abrasive material. So, looking at an example with concrete, in this case, we basically took a single sample from the client and cut it in half, and then sandwiched that material, each half of the cylinder, around the sensor to run the testing. Thermal conductivity in this way can be characterized across many different samples or in different locations with the same sample to help you understand the material's variability. So this is looking at 10 different locations in the same sample material, and you can see that the spread of the data is quite tight for a concrete material. This is quite a self-consistent type of concrete. The relative standard deviation of this data was about 3%. So that is the end of the technical material. I'm gonna turn it over to Adam so he can speak to our upcoming webinars and some of the other things we've got going on. So thanks,
Excellent,
Adam.
excellent. Thank you very much, Sarah. Just to confirm the audio is okay?
Yep.
Yep. Okay. Sorry, we're just having a little bit of difficulty with mics, but look, that was a great presentation. Um, really like it for its comprehensive view on different building materials and different scenarios. So certainly saw the concrete and cements and how we would deal with those with the TPS. We see the value of MTPS with a lot of other types of materials. Um, Interesting work being done with aerogels, with phase change materials. And I know just from the clients I work with directly, a lot of work in bio-based installation. So thank you very much, Sarah, for providing us a quick run through on how you approach those different situations with the available tools that Trident offers in the toolbox. In terms of upcoming webinars, we've worked closely with our partners around the world. There's a couple of partners in particular I'll draw attention to. So we've recently developed a new partnership with Metrovib from the ACOM group. They're one of the world leaders in dynamic mechanical analysis. We're representing them in North America here. And we're really pleased to put together a webinar with them coming up next week on testing polymers in rubbers materials, both measuring conductivity. That's C-Therm's particular niche, but also a lot of interesting application there in DMA testing. And I see Anna has put the links in for that upcoming webinar next week. Beyond that, we also have one scheduled for thermal interface materials later this month. So folks that are perhaps interested in electronics or thermal management of batteries and electronics, this would be a really good one to look at, where the conductivity is, of course, a critical performance attribute for any TIM material. And then we end the month with a real bang, excuse the pun, but looking at explosives. One of the first applications for the development of the MTPS sensor was working with the US Navy on the testing of explosive ordnance and looking at the stability life, shelf life of such materials. The thermal conductivity is really important from the stability, from the ignition of the material, very important from process safety and how they're handled and transported. So that'll be a nice webinar for anybody that's involved in process safety or explosives and looking at options to better characterize such materials. So I'll get you to advance to the next slide. A good cue for us to thank everyone. And I want to first start with Sarah for presenting a great webinar today on testing novel materials, which I know she's seen a lot come through the lab in the last few years. Behind the scenes, we also have Ana Paula de Castillo. She's a regional manager here at C-Therm Technologies. She's been helping us moderate the session. As some of you have been asking questions, she's one of the people responding in the chat box. And I know she's done a lot of outreach, in particular in Spain and Portugal and Brazil, in inviting folks to join us online for this experience, and really want to thank her for her efforts, as well as Stuart Hillhouse, who's in our marketing group. Stuart's done a great bang up job putting this together. He's put together a whole series of webinars. We're using a new platform here to help improve the user experience and has done a tremendous job, as evident in the amount of interest in today's webinar. This was the best attended webinar we've hosted to date. We had over 250 people register for the event and are really pleased in terms of that interest. But last, but most importantly, you, the participants, really want to thank you for joining us online. We know it's a busy time, it's a chaotic time. We really appreciate you spending an hour with us and the opportunity to share with you a little bit our experience in measuring conductivity of these types of materials. We'd be very pleased to continue this discussion on a one-to-one basis. So if you would like us to follow up with you, please don't hesitate to contact us. If you saw something that was interesting in all of this, you're interested in some budgetary pricing on the Trident system as an example, that's something that we can provide a quick quote on for budgetary consideration. Anna will be putting a link in just where to submit your info to receive a quick quote. And of course, we're also happy to follow up with a consultation. So if you would like to speak with a product specialist, we do also offer live video demos. This is something new that is a response to the COVID-19 situation, where we put in a new facility to offer live video demos. You can have screen sharing in that. We've got different cameras set up so you get a real bird's eye view of what the test looks like to operate. And we can even pick out some samples that really represent your type of user scenario. So I know, for example, Arya Hakimian that runs that facility has a number of different building materials, building construction materials available to demonstrate what this looks like in real time. So those are some options available to you. We'd be certainly very happy to offer. At this point, we're going to move on to the Q&A session, but I'm going to stop the recording here. The recording link will be sent out automatically. We've gotten a lot of questions on how to obtain a copy of the presentation. So fear not, there is a link coming your way that has the fully recorded presentation in it. So with that said, thank you again, everyone. If you viewed this as a recording, thank you as well, and hope you have a wonderful day.